Exploring the depths of space has always been a quest that stretches the boundaries of human understanding.
In less than 2 years since launching, the James Webb Space Telescope has changed the way we understand the universe.
The James Webb Space Telescope just found something terrifying, possibly a huge object in space. This extraordinary discovery is forcefully uprooting the foundations of everything we thought we knew about the cosmos. Scientists are in a fix as they now have to revisit their theories because the presence of this large space object is introducing strange rules in the universe. What is this big object detected in space? How far does its presence affect what we know about space? Join us as we examine the massive object that the James Webb Telescope detected in space and what this means for us. JWST discovers large black holes in space. The James Webb Space Telescope, fondly called the JWST, was launched into space on December 25, 2021, to observe and explore the inner workings of outer space for us. Since then, it made a massive leap in space observation for humankind because of its remarkably sophisticated instrument for infrared cosmology and astronomy. It is equipped with advanced features and capabilities that make it possible to study the farthest stars and galaxies from the Earth. One of these capabilities is its 21.3-foot primary mirror, which makes it the furthest-seeing space telescope ever built by humans. It'll be able to see using infrared rays, unlike Hubble's ultraviolet rays, giving it a deeper and clearer vision than the Hubble telescope. Infrared rays see more because it's the zone on the electromagnetic spectrum that has slightly longer wavelengths than visible light. As a result, the JWST is an infrared-only telescope capable of observing the most distant areas of the universe. It has an unusually sharp resolution and sensitivity that brings us a new depth toward observing the cosmos. One of the major achievements of the JWST is its uncanny ability to peer into the past to give us an inkling into how the first stars looked like and how early galaxies were formed. The data generated with this resolution and sensitivity helps scientists to calculate accurate analysis of the atmospheres of habitable exoplanets. The JWST just discovered the existence of large black holes in space. These massive objects make for a good study of the cosmos, and with the help of the JWST, experts can now look into the strange features of black holes that are littered all over the universe. Black holes are mysterious cosmic elements that were brought about by the remains of crumbling stars. They are known to exert such intense gravitational force that even light is subject to their pull. In the world of black holes, space and time are distorted by something called the event horizon. Scientists call the event horizon a point of no return. It is an area inside the black hole where surrounding matter, including light, is literally sucked into a point of no return by the black hole's forceful gravitational pull. The existence of such a phenomenon in the first place challenges the existence of modern physics. Black holes might be a discovery that seemed to have been made recently, but the theory of relativity already hinted at its existence years before it became known. The theory of relativity proposes that sufficiently dense mass can alter space-time to give rise to the strange structure of today that we call black holes. Black holes are easy to spot because of their inherent gravitational effect on surrounding cosmic bodies. The JWST especially, and other space satellites, make use of advanced instruments to fish out the clear traces of black holes' existence. Scientists have learned to make out the properties of black holes and their existence by closely observing how nearby gas and stars act around these black holes. They zero in on analyzing the gravitational effects on close stars, finding out whether they orbit or are pushed out by the intense gravitational pull. With the help of the James Webb Space Telescope, problems that couldn't easily be resolved have now been settled because of its sophisticated observatory capabilities. As a star and black hole approach each other, the entire surroundings get very bright. Though they make such a huge impact on surrounding matter, black holes have a really strange quality. The puzzling thing about them is that their dimensional measurement isn't yet defined as speculated by the theory of relativity. The reason for this is that the black hole's gravity controls the fate of any cosmic object that tries to come too close. The mystery of black holes is further explained by the no-hair theory. This theory postulates that once a black hole achieves stability after its formation, it has only three measurable properties, which are electric charge, mass, and angular momentum. This is a simplistic theory that hides the vast complexity of these cosmic elements, and it makes it hard to distinguish black holes from each other even if they have the same physical characteristics. In observing black holes, scientists spotted three different types, and they're all a varied family possessing unique features. Let's look into the types of black holes out there in space. Strange types of black holes. You won't have to look too long into the study of black holes before you come across the first type, which is the stellar mass black hole. They are the smallest black holes ever known, and they have a shocking weight of between 1 and 100 times the mass of our Sun. Stellar mass black holes are so surplus in the universe. In the Milky Way alone, there are an estimated 10 million to 1 billion of such black holes. It might sound a lot when viewed as a standalone number until you know that there are around 100 to 400 billion stars in our galaxy. Stellar mass black holes are birthed either from the joining of two neutron stars or the gravitational collapse of a single star. Then there are supermassive black holes, which are the far opposite of stellar mass black holes. These ones weigh anywhere from 1 million to 1 billion times the mass of the Sun. Scientific theories let us know that when massive stars come to the end of their lifespan, the energy from their explosion or supernova in the early universe creates supermassive black holes. These black holes have a mass denser than 1,000 suns. Supermassive black holes are always located at the center of a galaxy. When observing galaxies, you're almost always likely to come across a supermassive black hole at its center. This development could suggest that they were also created as a part of the formation of its galaxy. Standing in the middle of stellar mass and supermassive black holes are intermediate black holes. Their physical traits fall right in the middle of their opposing black hole cousins. A few decades ago, it was thought that intermediate black holes didn't exist at all. Recent studies and observations seem to suggest otherwise, as it's now widely believed that these types of black holes exist, but might be rare to come across. The reason for their rarity is that there aren't any common physical structures in the universe that can collapse matter down to a black hole of intermediate size. Also, most stars are simply too small to break down into an intermediate black hole, and that's why supermassive black holes are more common than intermediate black holes. Many people believe that black holes are always massive in size. On the contrary, there are black holes that are really small, almost to the size of an atom. It's almost impossible to imagine that supermassive stars can have such a tiny size while having such large and heavy mass, sometimes being more massive than a complete mountain. That's the reality of these stars and black holes. A close observation of the Milky Way will reveal black holes spread everywhere across the universe, with each having a mass equal to millions of solar masses. Experience and scientific theories have revealed that huge black holes tend to have a central position in galaxies. For example, at the center of our Milky Way lies the supermassive black hole named Sagittarius A, that has a mind-blowing mass equal to about 4 million suns. It's no wonder it's the largest object in its surroundings. Further research continues going on with black holes because of their interesting complexity, keeping scientists busy for decades. These mind-blogging black hole structures have become the laboratory where several theories deeply founded on the quantum domain and general relativity are cross-examined and investigated. Researching these cosmic objects has led physicists into virgin areas of physics, subjecting our current experience and theories to a solid validity check. Newer methods of observation keep refining our knowledge of black holes as we make good technological progress. However, One of the drawbacks of studying black holes is that we can't directly observe them, so our understanding of them and their intricate workings is severely limited. With the temperature of stellar mass black holes jumping to billions of Kelvin, scientists are restricted to using indirect methods and theories to understand them. At the heart of the stunning nature of black holes is the event horizon. It's a boundary in space-time where no element, including light, can escape. It serves as the basic feature of black holes, and it's more than just a simple, gravitationally powerful element. It is a region of reality that's beyond human understanding at this point in time. Looking into the event horizon, one can't help but think how the laws of physics suffer a profound shift, yet still offer sneak peeks into the unknown secrets of these cosmic agents. While there are many things we don't know about black holes, one thing scientists do know is how black holes are created. Let's take a look at how these space entities come into being. The creation of black holes explained. It's already a well-known fact that the gravitational collapse of stars leads to the birth of black holes. It usually happens when an object's internal pressure can no longer resist its internal gravity. Scientists drum the importance of a high-density environment for this collapse to occur in the first place. In our current era of the universe, you can only find such densities between stars. Surprisingly, during the early periods after the Big Bang universe, densities were remarkably higher than it is today. This sparked the creation of black holes. Aside from high density, the formation of a black hole requires the mass to be unevenly distributed to shield the mass from becoming uniform. For these primordials to be created in such dense environments, there must have been early fluctuations in density, which allowed them to grow through gravity. Still, gravitational collapse isn't the only way black holes are created. Another way they could be formed is through high-energy collisions with adequate density. However, events like this haven't been experienced lately. As of 2002, high collision events with such sufficient density haven't been seen directly or indirectly. Scientists check out for signs of it happening by mass imbalances in particle accelerator experiments. They are also fascinated by the complexities of black holes whenever they study them. What is the interesting nature of these black holes? How black holes behave. The most intriguing feature of black holes is their dynamic nature. You won't find these unique cosmic elements with a consistent size. Their sizes aren't static. They keep changing at every moment and growing larger by feasting on the surrounding matter. Black holes all survive by taking in as much gas and dust as they can in space. Their rapid eating of these gas and dust leads to their massive bursts of growth. This behavior is responsible for the formation of supermassive black holes that are littered all over space. Scientists have also proposed this process as a potentially possible way for the creation of intermediate black holes in spherical clusters. Black holes also have the ability to merge with other space objects like stars, or even join with other black holes to form a giant black hole cluster. This phenomenon keeps interesting scientists as they study it extensively to this day. With the addition of the James Webb Space Telescope, observations are now easier as these black holes can be probed to a depth not known before. Reports have been spreading around of a black hole invading our solar system and hitting the Earth. Considering that these black holes have a mass that's unbelievably bigger than many suns, it's a scary thought to imagine such a cosmic object crashing with our habitable planet. Fortunately, scientists have looked into this matter thoroughly and discovered that such a concern is uncalled for. They've put the suspicion and worry to rest by proving that it is impossible for such a scenario to happen. Scientists let us know that if a black hole were to replace the sun today with a similar mass, the Earth wouldn't be sucked into it like everyone would have you believe. We will not all be drawn into the event horizon of the black hole. The realistic occurrence will be that the Earth will rotate around the black hole in the same manner with which it currently rotates around the sun because of the equivalent gravitational pull coming from its mass. It will also interest you to note that black holes do not travel through space, swallowing up celestial entities like stars, moons, or even planets. That's not how they operate, so the possibility of it heading towards the Earth is virtually non-existent. The Earth would neither meet nor give in to a black hole, as they are not anywhere near our solar system to begin with. To finally put these fears to rest, the Sun cannot metamorphose into a black hole, as it doesn't have the mass required to collapse inward like aged stars do. The James Webb Telescope isn't just good for only observing close celestial objects. One of its hallmarks is that it detects cosmic entities from a distant past like it just did with black holes. What did the JWST discover from the past? JWST detects 400 objects close to our solar system. The James Webb Space Telescope, JWST, has just had a recent success in detecting around 400 objects that are dangerously close to the sphere of our solar system. Before now, these celestial objects have been largely unknown. Scientists received this discovery with merriment and renewed enthusiasm, as it indicates a profound shift accomplished by the telescope in our understanding of the vast universe. We should remember that Earth, galaxies, and stars are spread throughout space, and they only take up 5% of the universe. This knowledge keeps us in check and lets us know that there are so many possibilities and objects lurking around the universe. So many that we haven't even been able to scratch yet. As it is now, the JWST is a key player in helping us unlock all the secrets and unexplored regions of the cosmos. It keeps unlocking several mysteries and fixing the puzzle that has held humanity spellbound for years. The sophisticated telescope opens up a new pathway in space research, letting us unearth deeper facts about cosmic knowledge that currently lie beyond us. The telescope has not only found ethereal objects that are way beyond our imagination and are around the uncharted 95% of our universe, but it also aided us in understanding the mysteries of our planet, Earth. As the telescope diligently keeps watch through space and gives us vivid infrared images of exoplanets and black holes, we can't help but understand the innumerable amount of events that have happened in the vastness of time, yet remain secret in the dark cosmos. Due to this realization, it's crucial to uncover as much information about the universe as possible, along with its underlying rules and principles. From the very first light in the cosmos, the JWST helps us peek back into the past to see how the earliest lights from stars and other celestial bodies appeared. It also allows us to unravel the formation of distant galaxies through time with its crystal-clear imaging. As the James Webb Space Telescope continues its exploration, our outlook on astronomy will forever be subject to changes and continuous revisions. The effectiveness of the telescope has caused us to identify hundreds of ancient galaxies, with some of them dating back as early as 600 million years ago after the Big Bang. This level of discovery could only be possible because of the presence of the James Advanced Deep Extragalactic Survey Program, popularly referred to as Jades. The project ushers in the requisite knowledge for the initial stage of galaxy and star formations. The JWST was carefully made with the latest modern technology so it can shape the way we think and visualize the largeness of the universe. We'll now know better how to relate with a universe that's locked by time and space. Scientists aren't resting on their oars, as they've been putting in long hours of work into the success of this telescope. Every moment of the day and night, they are examining, unraveling, and constantly classifying the faintest images of distant galaxies. One of the scientists' key players was Ryan Ensley, who was a student at the University of Texas, Austin. He did research for his school, and the major focus of it was the galaxies that existed at the start of the universe, around 500 to 800 million years post-Big Bang. This era is recognized by the scientific community, and they actually have a name for it. It's called the Epoch of Reionization. Ensley and many other scientists have worked on this for years now, and from their investigations, it has become clear that immediately after the Big Bang, the entire universe was wrapped up in a fog of gas. This development made it opaque to rays of light energy for many years. The mist cleared up approximately around 1 billion years after the Big Bang. The departure of the mist brought in a severe level of darkness, and that was how the concept of reionization or cosmos transparency started. Part of the Jades program was that Ensley and his colleagues studied the galaxies with James Webb's near-infrared spectrograph, also called NIRSPEC. They used this instrument to find signatures of star formation. After lots of searching, they found so many of these star formations. Sharing his experience about it, Ensley said that almost every single galaxy that we are finding shows these unusually strong emission line signatures, indicating intense recent star formation. He also noted that these early galaxies were very good at creating hot, massive stars. Lots of theories by scientists about black holes flew around the place. Some of these scientists were pushing for the notion that these supermassive black holes or other galaxies merging with hot, youthful stars contributed to this profoundly transformative period. The large, bright stars emitted concentrated loads of ultraviolet light that transformed the nearby gas from opaque to transparent through the ionization of atoms, causing it to remove atoms from their nuclei. Due to the large proportion of big, hot stars, there's every possibility that they were the main cause of the ionization process. The later merging of the nuclei and electrons produces uniquely strong emission lines. During their investigation, Ensley and his colleagues also found evidence that the young galaxies passed through several periods of rapid star formation, with scattered periods of quietness where only little stars were formed. These stars might have taken place as galaxies caught clusters of gaseous raw materials needed to form stars. Also, since massive stars tend to explode quickly, they could have bombarded tons of energy into their surrounding environment from time to time, eliminating the possibility of gases condensing to form new stars. Probing further into the secrets of the universe, Jades takes the lead role by shining the spotlight on the early galaxies that were in existence when the universe was less than 400 million years old. Our entire cosmos was still in its infantile stage at that time. The advanced principles of this study are key to unlocking the secrets our universe holds. The reason for this is that when astronomers study it, they can see how stars formed in the early years of the Big Bang are different from what we see in our present times. Though the galaxies are many light years away from us, the light coming from them goes through changes when journeying to reach us on the Earth. They are stretched to longer wavelengths and get so reddish in color as the universe expands. This phenomenon of galaxy lights getting redder in color while traveling to us through the expansion of the universe is called redshift. By observing the redshift, astronomers are able to accurately calculate the distance of galaxies to learn how far away they are from us, and also when they existed in the universe's early stages. Before the JWST was introduced into the equation, there were only a few dozen galaxies that had a redshift exceeding 8. A redshift of 8 signifies an ancient period where the universe was younger than 650 million years old. Right now, however, the Jades have detected almost 1,000 of these extremely distant galaxies. Scientists work on characterizing a galaxy's spectrum, and conventional methods of doing this involve assessing and analyzing its brightness across many closely spaced wavelengths. There is an alternative to this, which involves capturing images of the galaxy through filters that each cover a narrow band of colors to get a couple of brightness measurements. At the same time, this facilitates the calculated estimation of distances for thousands of galaxies. The beauty of this approach is found in its efficiency, which gives scientists the ability to gain invaluable insights into outer space through the combined efforts of programs like Jades and cutting-edge technologies. Little by little, the puzzle of the cosmos is getting solved as we're beginning to get a faint glimpse of the earliest era of the universe's evolution. Ryan Ensley wasn't the only academician involved in this project. Kevin Hainline from the University of Arizona in Tucson assembled his colleagues to use Webb's near-infrared camera to get measurements called photometric redshifts. They also identified over 700 prospective galaxies that were in existence when the universe was between 370 million to 650 million years old. This finding shook the scientific community to its core as it was unprecedented, and a big step towards peeling off the mysterious layer of the universe. The unbelievable number of these galaxies far exceeded the earlier predictions made before the launch of the James Webb Space Telescope. Commenting on the achievements, Heinlein said, "Previously, the earliest galaxies we could see just looked like little smudges, and yet those smudges represent millions or even billions of stars at the beginning of the universe. Now we can see that some of them are actually extended objects with visible structures. We can also see groupings of stars being born only a few 100 million years after the beginning of time." One of Heinlein's colleagues, Ricci, also added, saying, "We're finding that star formation in the early universe is much more complicated than we thought." The results of the achievements by Heinlein and his colleagues are getting reported at the 242nd meeting of the American Astronomical Society in Albuquerque, New Mexico. Astronomers had very little understanding of how these distant galaxies evolved and came to be. Presently, the Space Telescope's exquisite sensitivity and resolution are allowing astronomers to get a clearer view of these faraway galaxies than ever before. JWST is bringing newer and more comprehensive perspectives of the cosmos that couldn't be captured by previous observatories like the Hubble telescope. Aside from finding new astronomical wonders and different celestial objects, the telescope has also been used to fish out exoplanets that might exhibit signs of life. The clamor for the exploration of extraterrestrial life keeps on reverberating in the world of scientists and even among society. People want to know if they're the only intelligent beings in the universe. The allure of finding aliens similar to us have captivated the fantasies of humans for a long time now. Scientists and astronomers are bent on getting to the root of this by utilizing the James Webb Space Telescope to scour for any precious sign of life in the dark cosmos. On its part, the JWST has regaled scientists and the world in general with stunning images of several celestial objects and exoplanets since its launch. Thanks to the latest space observatory, we can now clearly picture the atmospheric conditions of celestial bodies while exploring deep space for regions that humans can't reach by themselves. We now have a comprehensive view of the Milky Way and beyond, a crystal-clear image of the star system closest to us known as Proxima Centauri b, and several other novel findings that have thrilled us these past few years. Each of this pictorial evidence fills our minds with concrete possibilities of the cosmos, while igniting the imagination of scientists to push them into unearthing more secrets of the universe. With the James Webb Telescope stationed in outer space, we can conveniently detect massive objects such as black holes that lurk around in space. What do you think about the massive black holes detected by the James Webb Space Telescope? Drop your opinion in the comments, hit the like button, share, and don't forget to subscribe to the channel for more interesting videos.